Hello everyone. So let's now solve practice assignment week 10 question number 2. Which of the following statements are correct? Option 1. Maximum directional derivative at 0, 0 for the function f of x, y equal to mod of x plus mod of y. And it is saying that maximum directional derivative is 1. Now, if we want to find the maximum directional derivative, for that we need to calculate the gradient, and for that we need partial derivative. So if we try calculating the partial derivative at 0, 0, now first of all, we cannot calculate its partial derivative by just putting this as constant here. We cannot do that for this function here. Now f of h comma 0 minus f of 0 comma 0 by h, and this we would get is limit s tends to 0 mod of h by h, and we know this limit does not exist as the left hand side limit and right hand side limit will not be equal. So that means the partial derivative does not exist. So does the gradient. So we cannot find the direction derivative, and the direction derivative does not exist. So this option is incorrect. Second option, the graph of the linear approximation to a function f of x, y at a given point P is the tangent plane to f of x, y at the point P. Now, this is basically the geometrical interpretation of the tangent plane, that geometrically the tangent plane represents the linear approximation of the function, like how the function will behave around that point if it would have been a linear function. So that's why this option is correct. Option 3, a tangent plane to the function f of x, y exists at every point. We just now see in this function f of x, y equal to mod of x plus mod of y, and the partial derivative for this function does not exist, and if the partial derivative does not exist, we cannot find the tangent. So that means it is the tangent plane does not exist for a function at every point. It need not to be. Oh, sorry, it is incorrect. Option 4, all directional derivative of a function f of x, y at a point P are 0 if the tangent plane is parallel to the xy plane. Now we know that the derivative of a function actually represents the slope of the tangent line. Now here in multivariable case it would be a tangent plane. So that means if the plane is parallel to the xy plane, the partial derivative with respect to x and y both would be 0. So as the tangent plane is parallel to the xy plane, that means fx is 0 and fy is also 0. Now if we want to check whether the directional derivative would be 0 or not, we can find the directional derivative using gradient of the function at some point with dot product with the unit vector in which you want to find the directional derivative. And the gradient vector is represented by the partial derivative with respect to x and partial derivative with respect to y. And if we are going to take the dot product with any unit vector, we now know that these partial derivatives are 0. So this whole dot product will comes out to be 0. So that means if the tangent plane is parallel to the xy plane at a point, that means all the directional derivative of the function would be 0. So this option is correct. Thank you.